Hey friends, in our previous two lessons, we explored the concept of embeddings and did hands-on exercises using OpenAI API. We did stored embeddings temporarily in memory, calculated cosine similarity between documents, and handled real-time queries. While this was great for learning, this approach is not scalable for real-world applications. So let's quickly understand why this approach does not scale. Number one, high memory usage. Each embedding contains 1536 float values, typically taking around 13 KB embedding space. Working with large datasets with thousands of millions of embeddings into memory becomes impractical. Second, inefficient querying. We recomputed embeddings at query time instead of storing them, which leads to unnecessary delays. Third, slow similarity search. We compared every embedded document using cosine distance in a linear search, which becomes extremely slow as data grows. Clearly, this is not a production-ready solution. It's fine for small-scale demos, but can't handle large or growing datasets effectively. So what's the solution? We need a more efficient, scalable approach. And here comes vector databases. In a vector database, embeddings are pre-stored and don't need to be recreated for each query. Similarity searches are handled quickly and efficiently. The architecture is built to scale for large datasets. Hi, I'm Anuradha, and today's lesson we'll dive deeper into vector databases. We'll discuss how vector databases work, popular vector databases available in the market, and a detailed hands-on example using the Netflix title dataset to build a semantic search application integrated with ChromaDB. Here's how a typical embedding application works. The document to be queried are first embedded and stored in a vector database. When a user submits a query through application interface, the query is also embedded and used to search the database. This query could be a semantic search or even recommendation system. The vector database efficiently finds the most similar documents and returns the result to the user via the application interface. Let's see how vector databases differ from traditional SQL databases. Most vector databases fall under the NoSQL category. In SQL databases, data is stored in rows and columns. Data is scalar in nature and optimized for transactional operations using SQL queries. In vector databases, the stored data is vector embeddings, which are high-dimensional data optimized for similarity searches, unlike the row-column format in SQL. This data format is specifically designed for vector operations efficiently. There are many databases available in market widely, and popular options include Pinecone, VB8, ChromaDB, and much more. For this lesson, we will focus on ChromaDB, an open source vector database. Let's get started with ChromaDB to understand the fundamentals. So now what's next we will be doing here? In this hands-on example, we will now move to our Jupyter notebook to get hands-on with ChromaDB using the Netflix titles dataset, and here's what we will be covering. We will be first connecting to the vector database, creating a collection which is similar to tables in SQL databases. We will add data to the collection. We will learn to query and update. We will perform the semantic search. We will refine the search with metadata filters, and we will come up with amazing semantic search for Netflix dataset. So let's get started step by step. Let's move on to our Jupyter notebook. As a first step and as a prerequisite to this script, make sure that you have created a developer account with OpenAI, you have added your payment method, you have installed OpenAI library and loaded OpenAI key securely in environment file and fetch it through load.environment library in Python, and finally that you have created OpenAI client using your key so that you can finally make API calls through chat completion and embeddings. And in case you are not aware of these steps in detail, please follow my first tutorial in this series, which is setting up environment for OpenAI. And so let's proceed from there by duplicating this script which we created in our first tutorial so that we can proceed from the next step from this point where we have already created client. So once you have adjusted the title of your Jupyter notebook, let's begin from here, and you need to install ChromaDB first. And it's a simple pip command which you can execute in your Jupyter notebook or in terminal as well. This particular thing will install ChromaDB core package, which will let us use the database directly inside our Python program. This is also called the local mode, where we are not using any client server setup, which is actually another mode of ChromaDB installation, which is used for large production setup application. But in our case, we are simply using local mode, which is just perfect for our learning and quick start. Once installation is complete, let's import two libraries. First is ChromaDB, which is the Python client for Chroma vector database. It will let us create and manage collection of vectors, let us do vector operations like add, update, query, which we will be doing soon. Another is OpenAI embedding function, which is simply a utility to connect ChromaDB with OpenAI embedding function. Otherwise, what we have to do, we would have to manually generate embedding using the OpenAI API and then pass the vector to ChromaDB. Next, we need to create a database client, and this client connects to our ChromaDB database and tells us where to save the data. Now, since we are using local mode, database will be saved right on our disk, and that is what we are passing over here, the path where we need to save the vector files. Why it is called persistent client? Because even if we are shutting down the computer, our data will be safe, it will not go away, and that is why persistence is there. Now, before we add to Netflix dataset, let's first see how we can create collection in ChromaDB. Collection is like a table in SQL, and to create it, we need to use our client and .create underscore collection method. To this method, we can pass the name of collection where we want to store particular files. We need to specify what embedding function we are going to use, and for that we have already imported OpenAI embedding function, and to that again we need to pass the model we want to use, and which is text embedding, small model in our case, and also we need to pass the OpenAPI key which we have already generated. Get or create true is a parameter where if the collection is already existing, let's say we run this script again, and if we do not have this parameter, it will give us the error that the collection is already existing. So it takes care of that if the collection is already existing, Chroma will reuse it, otherwise it will create a new one. Let us create another collection, which is again, collection is similar to SQL tables. So now we have created two collections, and we can check all the collections in our database with the help of list underscore collections method. So effectively it gives us two collections so far we have created. To a particular collection we can add documents, which is like inserting rows in a SQL table. We can pick up the collection object, and to that we can apply add method. Let's say we have to insert only one data. We need to have ID of the document which we want to insert. What is the content of the document? So that we need to pass as list. So let's say this is our document. So this is how we can add document to our collection. On the similar lines, we can also add multiple documents simply by adding in this list. We can check the count of documents inside a collection with the help of count method, and since we added one over here and two further to that, we have total of 3 docs in our collection. And remember, you specified a path when creating a client, and if you observe, a path is created over here and it has got the documents inside it which are embedded using this function, OpenAI embedding function. Now, in order to retrieve the document inside this DB, we can again use the IDs which we specified while adding the document to collection, and when you will retrieve particular document, it will specify like this. Let's talk about this. ID is the unique identifier for each document. Like we already added that, like we have a primary key in SQL. Then we have documents, which is the original text we are storing in the database. And then we have embeddings, which is currently shown as none. We'll talk about it. And then we have metadata, which is the additional information like tags or titles, which we will be looking at when we will be talking about refining the queries. And like for example, in case of movies, title can be one metadata, or the type of show like movie or drama can be another metadata, or release year can be another metadata, which reflects the information about that particular document, and that is used in filtering out the document. We will be looking at it. Now, in order to fetch embeddings which are already generated, we need to explicitly request embeddings when using get method. And this is how we will be doing get IDs. We will be specifying the IDs, and whatever we want to include, we will specify that. So you see over here, we have ID, we have embeddings, and further to that, we already got the documents over here. Metadata we supplied none, and this is the document one. Perfect. Now let's perform vector operations on Netflix title data set, and this can lead to initial steps of building of recommendation system or semantic search applications. Movie data set, make sure you have this Netflix underscore titles.csv in your repository. You can obtain it from my GitHub repository, which is also given in the link. I have limited the data to 100 rows in order to save the token, and it has different kinds of data related to a movie, including title, show ID, and description about it, and where it is listed, in what kind of category, and more, right? So since we need to have a unique ID for a document, let's pick show ID as a unique ID, which is like a primary key in a SQL. And we will also add metadata in this case, and let's pick the type of the show as the title and as metadata. And one more thing, we can take release here as a metadata. So this is the attribute related to our document. In order to form our document, we can club couple of fields like title, type, description, categories, so that we can have a rich context in embedding, and we can have a better search or recommendation system. And to do this, we need to import CSV. We will be using CSV module for this, so that we can perform operations on the row. We can extract data of each row in the list IDs, metadata, documents as discussed. It will set the cursor on each row every time we are doing this operation through for loop. We are fetching ID, document, and adding it into the corresponding list. Let's run this, and let's check the sample of just one element. So let's say these are the first two elements of the list, which has ID s1, s2, and these are the documents which we have created with the help of this. Apart from that, we have the metadata. We can better view this documents, something like this. So these are the documents which we have created. So this is just for better readability. So we have documents ready, and now we need to create a collection in ChromaDB for these Netflix titles, and then add all these documents in that collection. So to create collection, we already know, we did it in case of sample data. In a similar manner, we will create collection for Netflix titles. Let's name it as Netflix titles, and we are using OpenAI embedding function with this model and this key. Let's list the collections in this case. Now earlier we created two collections, right? Test titles 1 and test title, and now we have one more collection, which is Netflix titles over here. Since our data set is just 100 rows, we can bulk insert the entire Netflix data set in one go, including IDs and metadatas, in this manner by passing it to add method. In case our data set is large, we can use chunking of data with the help of batch size. which we can pass in loops or something like that. So for now we are doing bulk insert. I hope it is done. So what we can do, we can print the number of collections in the number of documents in the collection, which amounts to 100 as we expected, and we can also query the collection now with the help of one of the movie ID, and it gives us everything. And if we explicitly request embeddings, we can get that too. So right now for this collection we have ID S1 embeddings, right? We can fetch it later, and then we have metadata and document. So we have in one step added all this to ChromaDB, including embeddings, metadata and documents, everything, right? We can also update this dataset. We can always update this details of metadata or IDs or documents using the update method. And in case you want to add new item to this collection, it is super simple. Simply use add method and pass the values like we have been passing. All right, so we have a collection of 100 documents, embedded 100 documents in our ChromaDB for now. Let's see an example of how we can semantically search particular movie using a query string. Let's say we want to search crime TV show, which we can pass as a query string in a list. We can add multiple items to this query, and how we can retrieve the data from this collection. And this can be done with the help of simply a query method of ChromaDB. Let's first apply that. Let's create a variable called result, and we have a collection named Netflix_collection, and to that we can use query method, and simply we can pass the query text as a parameter, which is query strings is basically a list of queries. Right now we have only passed one query to this list, but we can have more elements added to it. And let's say we want to retrieve the closest two results of this. Now this query method is basically used to find the most similar document to a given query using vector similarity, like we used in cosine similarity method earlier in our previous lesson, or when we explained text embeddings. So let's print the result. All right, so we asked for a crime TV show, and hopefully it gives us two results, right? We asked for two results. It gave us the document IDs S15 and S3, and it also showed how much closer they are to the result, and more than one means they are far in similarity in terms of, so they're less than one over here. And it is also giving the metadata. So one is release year, type TV show, and both are release year 21, and then it is giving the title crime stories, and the other also is seems like related to crime TV show. Effectively, just with this query method, we are able to retrieve the collection of the most similar documents to the given query. And so it makes sense how useful this ChromaDB is. Let's say we give comedy TV show over here. In that case, what we will obtain is the most closest result and we will get the titles related to comedy. We can always view this result in better manner with the help of Python. We are zipping the result and fetching each of the result document metadata distance and displaying it. So effectively for this comedy TV show, the result is this, and we are displaying it in this manner. And this confirms that yes, this is the closest result possible over here. And let's see an example where we can pass multiple values in a query string over here. Let's name it as query string 2. Let's name it as comedy, and let's say we have kids. So when we are passing this query method, all right, what it is doing, it is also embedding the query and then applying vector similarity over here. So we have this result 2. Let's say here we are passing this query string 2, which has 2 values in it, and let's say we get this result. Okay, whatever it is, and maybe I can use this to better display. So we have this. Okay, we have to pass result 2 over here. Let's use something else. Trailer. Okay, so query string 2 trailer, and we have some different result this time. All right, so we have some result. Let's fetch more results this time. Let's say if we fetch 5 results this time, and each has its own release here, and all we want is to filter out the result on the basis of year. What we can do, we can use where command in our query over here, where we can simply specify where is equal to, and the name of the attribute is release year, and where we can use simply the metadata over here actually. So release year is, let's say, 2021. So let's run this and let's see the result. So this time it will give me the results related to 2021, and so with the help of metadata, effectively we can pass it in the query to filter out our results. We can pass multiple filters in one go with the help of where command. Let's say instead of this we pass where, and here we are specifying that this is and condition, where this is a movie and it is from the release year 2020. So let's just pass something else over here, comedy kids, so we get better options. There are some results, and let's just see this. So it has year 2021 and all are of type movie, and not a single one is show, and that is where we are making use of metadata, first to make our embeddings rich, and second to filter out the queries.